We've all been there, right? You build this beautiful, super fast application, you're so proud of it, and then you watch it completely crumble the second the user's internet connection flickers. Well, today, we're going to talk about how to solve that problem for good.
So meet Timothy. He's a junior developer, and this is pretty much his cry for help. I mean, he did everything right. The animations are smooth, he's running data parsing on a separate thread, his app is a performance masterpiece. But then his client's CEO gets on the subway, loses Wi-Fi, and the app doesn't just slow down, poof, it's gone.
And what's in its place? Oh yeah, the dreaded Chrome dinosaur. Look, this little guy isn't just a cute loading screen, it's a symbol of total catastrophic application failure. It means all that hard work, all that optimization, is completely worthless without a perfect, constant internet connection.
This is where Timothy's senior colleague, Margaret, steps in and just reframes the entire problem perfectly. She tells him, look, this isn't a technical bug. It's a failure of customer service. You've basically built this incredible experience inside, but you have no one, absolutely no one, managing the front door when things go wrong outside.
So if the problem is the front door, well, the solution is to hire a fantastic maitre d'. And this is where the hero of our story finally arrives, the service worker.
Now you might remember, just last week, Timothy hired what we could call a sous chef. That was a web worker. It's great for handling heavy computational stuff in the background, keeping the main thread free. But a service worker? Totally different. It's not in the kitchen chopping vegetables. It's the maitre d', standing right at the front door, meticulously managing every single thing that tries to come in or go out.
Okay, so in more technical terms, what is it? A service worker is a special JavaScript file that the browser runs in the background, totally separate from your web page. Think of it like a programmable gatekeeper, a proxy that sits right between your application and the wide-open internet.
And that simple idea is really where the magic is. Once you hire a service worker, every single network request your app makes, I mean everything, whether it's for an image, a CSS file, or API data, it has to go through the maitre d' first. The service worker gets to decide what happens next.
So how does this maitre d' actually do its job? How does it intercept all those requests and make sure that Dinosaur never, ever shows its face again?
Well, Timothy followed 3 basic steps. First, he registered the worker, which is basically telling the browser, hey, I'm hiring this maitre d'. Second, during what's called an install event, he told the worker to take the app's core assets, the HTML, the CSS, the JavaScript, and stash them away in a local cache. And third, he told it, okay, you're on duty. Start intercepting every single network request.
The bottom line here is just so powerful. You are no longer at the mercy of the browser's default behavior. Instead of your app just failing when the network fails, you are now in control. You get to decide what happens when a request goes out. And the strategy Timothy used is called cache first. And honestly, it's beautiful in its simplicity. When the app asks for something, the service worker first just checks its local cache. If it finds a copy there, boom, it serves it up immediately, without ever touching the network. Only if it's not in the cache does it even bother trying to go out to the internet.
And now we get to the payoff. We've hired the maitre d', we've taught it the cache-first strategy. It's time to see what happens when those delivery trucks actually hit traffic.
Okay, so Timothy goes into his developer tools, he gets the worker installed, and then he deliberately switches his browser to offline mode. He kind of holds his breath and hits refresh. What happens next?
Before, this was the result. Instant failure, a blank white screen and a pixelated dinosaur. The world-class restaurant kicking all its paying customers out onto the street.
But after implementing the service worker, the application is alive. The dinosaur is gone. It's been defeated. The restaurant's front door is wide open for business, even when there are no deliveries coming in.
Now, let's be really clear about what this victory means. The application shell, the HTML, the styling, the core JavaScript, it all loaded instantly from the cache. Now, of course, the live data grid was empty because it couldn't reach the API. But the crucial part, the game-changing part, is that the application was there. It was alive, it was intact, it was responsive. It was a graceful experience instead of a catastrophic failure. This is incredibly powerful stuff. But, with great power comes a couple of golden rules you absolutely have to know before you dive in. So here they are, Margaret's 2 golden rules. First, because service workers can literally intercept and even change network requests,
Browsers require that they only run over secure HTTPS connections. This is a huge security feature that prevents so-called man-in-the-middle attacks. And second, they have a kind of tricky life cycle. An updated service worker won't actually take control until all the old tabs of your app are closed, and that's something you definitely have to plan for.
So why does all this matter so much? Well, because what we've just described, this ability for an app to work offline, to be reliable no matter what the network is doing, that is the absolute bedrock of what we call progressive web apps, or PWAs. It's what lets a website start to feel as robust and dependable as a native application you'd install from an app store.
So, as we wrap up, I'll just leave you with this one question. You might have the fastest kitchen in the world with perfectly optimized code running like a dream. But if you haven't hired a maitre d' to manage your front door, are you still leaving your users out in the cold the moment the network gets just a little bit bumpy?